The heart is a muscular organ that pumps blood throughout the body. Heart valves are made of leaflets, which are thin but strong flaps of tissue that act like donors between the heart's chambers and major blood vessels. They open and close to let blood flow from one area of your heart to another at the right time and in the right direction. The four valves of the heart are the tricuspid valve, pulmonary valve, mitral valve, and aortic valve. Each valve has a specific location, structure, and job. The tricuspid valve has 3 leaflets to allow blood flow from the right atrium to the right ventricle and prevent blood from flowing backwards. The pulmonary valve has 3 leaflets to allow blood to pump from the right ventricle to the pulmonary artery and prevent blood from flowing backwards. This artery leads to the lungs, where the blood picks up oxygen. The mitral valve has 2 leaflets which allow blood flow from your left atrium to your left ventricle and prevent backward flow. The aortic valve has 3 leaflets which open to let blood flow from your heart's left ventricle to the aorta and prevent backward flow. The aorta is the largest blood vessel in your body, bringing oxygenated blood from your heart to the rest of your body.
What happens when something goes wrong with these valves? Let's run you through a scenario. Mr. X is experiencing some concerning symptoms. He has a shortness of breath, particularly when lying down, a rapid pounding heartbeat, and his ankles have swelled up. In light of this, he decides to take himself to the emergency room.
So how do doctors detect the problem? For example, at a patient's appointment, they may receive a thorough physical examination wherein the doctor hears a whooshing sound whilst using a stethoscope on the patient's heart and lungs. The doctor recommends that the patient receives an echocardiogram or a cardiac MRI. An echocardiogram uses sound waves to create pictures of the beating heart and can show the mitral valve and blood flow within the heart, whilst a cardiac MRI provides detailed images of the heart structure and function. Both options can help detect problems with the valve functioning. The patient receives an echocardiogram which confirms they have a mitral valve regurgitation.
So what happens when the mitral valve is damaged? The mitral valve regurgitation occurs when the valve fails to close properly, leaking blood backwards across the valve. If the leak is severe, not enough blood is moved through the valve correctly, and therefore not enough blood is pumped throughout the body.
When left untreated, mitral valve regurgitation increases stress on the heart muscles, leading to dilation and scarring. Dilation occurs due to the volume overload in the left ventricle, as it adapts to maintain the new output of blood required. This then results in additional pressure on the heart muscles. This chronic stress triggers ventricular remodeling, a process by which the heart increases in size to adapt to the new demands. However, this can also create an increased risk of arrhythmias and heart failure. If left untreated, long-term mitral valve regurgitation can raise pressures in the pulmonary blood vessels in the lungs, causing fluid buildup. As the efficiency of the heart decreases, reduced blood flow to the kidneys may occur. This can result in the impairment of the kidneys to filter waste products from the blood efficiently, leading to kidney failure. Fluid retention is also a symptom resulting in the swelling of the lower body. This can further affect the kidney, causing them to retain salt and exacerbate the problem.
Mr. X attends a follow-up appointment to discuss his options of treatment. As his condition is not quite severe, Mr. X is able to be prescribed some medicine to combat his symptoms. These may include water pills to reduce or prevent fluid buildup in the lungs and other parts of the body, blood thinners, also called anticoagulants, to prevent blood clots, or blood pressure medicines to lower blood pressure. If his symptoms and condition worsen in the future, Mr. X may be recommended for mitral valve repair surgery, wherein the surgeon may patch holes in the heart valve, reconnect the valve flaps, remove excess tissue from the valve so that the flaps can close tightly, repair the structure of the mitral valve by replacing cords that support it, and separate valve leaflets that have connected. In the most severe cases, mitral valve replacement may be recommended, where the surgeon removes the mitral valve and it is replaced with a mechanical valve or a valve made from cow, pig, or human heart tissue.